Welcome to today's Explainer. Let's just dive right in, shall we? I want you to picture this. You've just been tasked with designing the enterprise architecture for a massive global healthcare company. They've decided to use Salesforce as their central customer engagement platform, and the scale we're talking about is absolutely staggering. You're dealing with 18 million patients, 250,000 healthcare providers, and dozens of different hospitals and clinics. Now, that sounds like a fantastic project, right? But lurking just beneath this massive footprint is a brilliantly complex architectural challenge. It's the kind of puzzle that truly separates a pretty good design from a world-class enterprise-grade system. And to put into perspective why the stakes are so incredibly high, just look at this number, 500,000. That's the sheer volume of appointment requests this system has to process every single day. And it's not just about the raw volume either. You've got patients booking from mobile apps, websites, call centers, and even partner clinics. Plus, there's a huge catch. A time slot can only be confirmed after checking 6 different downstream systems. We're talking systems managed by entirely different teams, all responding at wildly different speeds. It's basically an absolute pressure cooker of data orchestration. So, here is our game plan for how we'll deconstruct this challenge. First, we'll look at the booking challenge. 2, the event-driven solution. 3, preventing duplicate appointments. 4, handling system failures. And finally, 5, scaling to 5 million.
Let's kick things off with Section 1, the booking challenge.
When a patient actually clicks book, Salesforce has to verify availability across electronic medical records, doctor calendars, and lab schedules. The core business requirement staring us right in the face is 2 seconds. The user absolutely must receive an acknowledgement within 2 seconds of clicking that button. But here is the brutal reality of the situation. Some of those downstream systems, they can take up to 15 seconds to respond. And honestly, sometimes they just time out completely. If you try to force Salesforce to wait for all those systems to reply synchronously, you are instantly going to hit governor limits. The system is going to freeze up, and your patient is just going to be left staring at a frustrating spinning wheel. So, solving this requires a massive mindset shift. You really have to start thinking like a principal architect here. As our source material points out so perfectly, you shouldn't even design this as an appointment booking system. You really need to design it as a distributed orchestration platform. The biggest trap you could possibly fall into is trying to perform all those validations synchronously. It all comes down to clearly understanding your system boundaries. Salesforce is your engagement layer. It owns the patient experience, the lifecycle of the appointment itself, customer notifications, and the audit trail. But look closely at what it does not own. It doesn't own doctor availability, it doesn't own insurance rules, lab schedules, or the operating theater schedule. Salesforce should never become your enterprise service bus. It just shouldn't be making all those complex scheduling decisions itself. Moving right along to Section 2, the event-driven solution. So, how do we satisfy that strict 2-second rule without hitting those dreaded governor limits? We have to decouple the entire process using a concept called eventual consistency. Instead of making the user wait 15 seconds just to see if their insurance cleared, the system acknowledges the request immediately. Then, the actual final state, whether that appointment is officially confirmed or rejected, gets processed asynchronously behind the scenes. Let's walk through exactly how this flows in practice. When the patient clicks book, we intentionally don't create an appointment record right away. That avoids creating dirty data if something fails later. Instead, step 1, we save an appointment request with a status of received. Step 2, Salesforce instantly publishes a platform event. Step 3, we return a request received message to the patient, easily within our 2-second window. And finally, step 4, MuleSoft picks up that platform event and takes over the heavy lifting, orchestrating all those downstream APIs asynchronously. Now, you might be wondering, why bring MuleSoft into the mix? Why not just write some custom Apex code directly in Salesforce? Well, because MuleSoft is built specifically for this exact kind of enterprise integration. It natively handles parallel API calls without breaking a sweat. It has built-in circuit breakers for when a system inevitably goes down, along with retry frameworks and dead letter queues. It also seamlessly manages API throttling, which is absolutely vital when you're dealing with older, heavily restricted downstream systems. All right, let's jump into Section 3, preventing duplicate appointments. This is a classic edge case that CTOs just love to ask about. What happens when an anxious patient sits there and clicks book 5 times in a row? Or what if they try booking on the mobile app and the website at the exact same time? We absolutely cannot have double bookings in healthcare. The secret weapon here isn't Salesforce duplicate rules. Those are slow, fuzzy, and meant for a user interface, not high-speed integration. The real solution is idempotency. This is a deterministic property where submitting the exact same request multiple times safely produces the exact same result without spinning up a huge mass of duplicate records. Here is how that brilliantly simple mechanism works on the platform. You take the patient ID, the doctor, the date, and the specific time slot, and you generate a SHA-256 hash. You then store that unique hash as an external booking key. Now, every single time a booking request comes in, it just performs an upsert using that external ID. So no matter what channel the patient is using, even if they spam that booking button, the system just returns the existing single source of truth. It's incredibly clean and honestly super efficient. Next up, Section 4, Handling System Failures. Let's be real. In a highly distributed healthcare system, things are going to break. Systems will go offline. So we need to explore how we handle these failures while maintaining total reliability. Take our insurance provider integration, for example. Let's say they have a hard limit allowing only 100 concurrent API requests. If Salesforce tried to handle a traffic spike directly, it would crash hard. But by offloading this over to MuleSoft, we can utilize a worker pool and a semaphore. MuleSoft basically keeps exactly 100 active requests going at any given time and safely queues up the rest. Salesforce doesn't even care. That appointment request just sits happily in an insurance pending status until MuleSoft is ready to circle back with the result. And what about real-world clinical emergencies? Let's say a doctor suddenly calls in sick and has to cancel. The EMR system publishes an event. MuleSoft routes it to a Salesforce platform event, and that triggers a standard flow to instantly update the appointment status to reschedule required and notify the patient. If an MRI machine breaks down, it's the exact same pattern. A system event triggers a flow to create a case and notify everyone impacted. The beauty here is that we are handling incredibly complex, unpredictable emergencies entirely without having to write custom Apex. Of course, to keep an eye on all this distributed complexity, you need a seriously robust observability strategy. A business dashboard in CRM Analytics can track things like wait times and rejected appointments. Meanwhile, an integration dashboard using tools like Splunk or Datadog monitors API latency and retry queues. And finally, a platform dashboard relies on event monitoring to catch flow failures or governor limit warnings. Because everything uses a correlation ID, your audit trail remains completely seamless from end to end. Which brings us to our final section, Part 5, Scaling to 5 million. So here is the ultimate stress test. The business loves your architecture so much that usage grows 10x practically overnight, hitting 5 million daily requests. Do we tear the whole thing down and start from scratch? Absolutely not. Expanding the infrastructure rather than constantly rewriting your business logic is the true hallmark of enterprise scalability. To hit that 5 million mark, we keep Salesforce doing exactly what it's doing, acting as the engagement layer. Instead, we scale MuleSoft horizontally by region or hospital. If platform events start to bottleneck, we can introduce a high-throughput backbone like Kafka or Azure Event Hubs. We move our long-term audit data out to Snowflake, and we implement intelligent queue prioritization, ensuring that clinical emergencies are always processed faster than routine checkups. Let's tie this all together. Looking at our core architectural principles, we achieved lightning-fast responsiveness through asynchronous processing. We tackled massive scalability by relying on an event-driven architecture. We guaranteed reliability using dead-letter queues, and we kept the entire system highly maintainable by minimizing custom Apex in favor of standard out-of-the-box tools like Flow and platform events. Which leaves us with one final, really important question to ponder. What truly sets apart a world-class, certified technical architect level design? Honestly, it's not just about knowing every little feature of a platform. It is knowing exactly how to orchestrate those features across a complex enterprise without forcing massive synchronous bottlenecks. It's about fully embracing eventual consistency. So I'll challenge you with this. Where in your own systems are you forcing things to happen synchronously that really truly should be event-driven? It's a real game changer. Think about that as you design your next big solution. Thanks for hanging out with me for this explainer, and keep building brilliant architectures.